One of the biggest reasons why we humans have continued to thrive is our constant urge to innovate. Through constant betterment, not only have we made life easier, but also discovered more about the universe than ever before. Our thirst for exploration has now pointed us towards the stars. NASA has been at the forefront of space exploration for decades, and now new reports suggest they may have finally perfected a new LightSail engine that breaks the laws of physics. Let's talk about this engine and what makes it so special. The vastness of space is one of the greatest mysteries out there. No one knows how big the universe is. The only perspective we have of its magnitude is capped due to our technological limitations. This has been one of the biggest hurdles in our quest for space exploration. Over the decades, organizations such as NASA have devoted significant resources to exploring our solar system. Even that has been a massive challenge due to the sheer size of our celestial neighborhood. Just a few years ago, the Voyager missions became the first man-made crafts to leave the solar system and travel to deep space, a feat that took multiple decades to accomplish. This is one of the many reasons why NASA has been hard at work to develop alternative methods of propulsion that would help us travel in space faster and more efficiently. Recent reports state that NASA has designed a near-light-speed engine that breaks the laws of physics as we know them. This new engine is said to accelerate to 99% of the speed of light, all without the need for propellant. The idea has been developed by NASA engineer David Burns in his spare time, and on paper, it works by taking advantage of how mass may change at relativistic speeds. However, the report is yet to be reviewed by his peers. This study has understandably sparked interest comparable to that witnessed in the early days of the EM drive. For a bit of context, it's important to know that the aforementioned EM drive was NASA's first foray into the idea of actually trying to build an engine capable of faster-than-light travel. First introduced by Roger Scheuer, a British chartered electric engineer with 48 hours of experience in the space and defense industries, in 2001, EM drive is a radio frequency, resonant cavity thruster idea with possible uses as a spaceship thruster. It is claimed to create thrust by internally reflecting microwaves, in violation of the law of conservation of momentum and other physical principles. The media has frequently referred to the gadget as the impossible drive. Explanations for how the EM drive could function go beyond the limits of known physics. Perhaps it's interacting with space quantum times vacuum energy, even though space quantum times vacuum energy doesn't enable anything to push off of it. Perhaps our notion of momentum has been shattered. Perhaps it's brand new physics as announced by the EM drive test. There is no official design for this device, and neither of the persons who claim to have developed it has committed to explaining how it may function as a thruster or what elements constitute it, making it impossible to determine whether a particular object is an example of such a device. NASA's Advanced Propulsion Physics Laboratory reported observing a small apparent thrust from one such test in 2016, a result that has not since been replicated. Subsequent studies have indicated that the thrust observed was a measurement error caused by interactions with the Earth's magnetic field or thermal gradients. In March of 2021, scientists from the Technical University of Dresden published 3 papers explaining that it was a total fluke. The thrust was explained by outside forces. As for the Helical engine, while it is intriguing, it is unlikely to defy the laws of physics anytime soon despite the claims. Although it has been met with skepticism from some quarters, Burns believes his concept is worth pursuing. In its simplest terms, the engine works by taking advantage of how mass changes at the speed of light. One way to break down this concept is to envision a ring inside a box, attached to each end by a spring. When the ring is sprung in one direction, the box recoils in the other, as is described by Newton's laws of motion. Every action must have an equal and opposite reaction. When the ring reaches the end of the box, it will bounce backward, and the box's recoil direction will switch too. However, if the box and the ring are traveling at the speed of light, things work a little differently. At such speeds, according to Albert Einstein's theory of relativity, as the ring approaches the end of the box, it will increase in mass. This means it will hit harder when it reaches the end of the box, resulting in forward momentum. Generally speaking, the engine itself will achieve a similar feat using a particle accelerator and ion particles. This is because chemical, nuclear, and electric propulsion systems produce thrust by accelerating and expelling propellants. Deep space travel is often a trade-off between thrust and large propellant storage tanks that eventually limit performance, and this is what makes this idea so compelling. Dr. Burns states that the objective of this paper is to introduce and examine a unique engine that uses a closed-cycle propellant. The design is capable of producing a thrust up to 99% the speed of light without breaking Einstein's theory of relativity. However, the plan does breach Newton's law of motion, violating the laws of physics. That's not the only thing holding the helical engine back. Scientists believe the engine would have to be 650 feet long and 40 feet wide to work. Additionally, it would only operate effectively in the frictionless environment of deep space. While the M drive has been proven to not work and the helical engine is yet to be properly reviewed, NASA has continued to fund research in an attempt to look for more alternatives. Most recently, the agency has announced it is investing $2 million over the next 2 years to advance the development of a new solar sail concept called diffractive light sailing. With diffractive light sails, NASA could potentially propel a constellation of science spacecraft into orbit around the sun's poles, something that's difficult to achieve using conventional spacecraft propulsion. Much like how a sailboat uses the wind to move forward, solar sails use the pressure exerted by sunlight to propel a vehicle through space. Large sails made up of reflective material like mylar capture the momentum of the sun's photons. The photons bounce off the sail, sending it in the opposite direction. However, as NASA points out, existing solar sail designs rely on very large and very thin sails. The direction of the sunlight also limits them. In other words, it's hard to navigate without sacrificing solar power. By contrast, diffractive light sails would use small gratings embedded in thin films to diffract the light, spreading it out as it passes through a narrow opening. This would allow a spacecraft to make more efficient use of sunlight without giving up maneuverability. Scientists state that diffractive solar sailing is a modern take on the decades-old vision of light sails. While this technology can improve a multitude of mission architectures, it is poised to highly impact the heliophysics community's need for unique solar observation capabilities. The Diffractive Solar Sailing Project is part of NASA's Innovative Advanced Concepts, or NIAC, program. The latest round of funding is part of the project's advancement to Phase 3 of the NIAC. So far, scientists have designed and tested different types of diffractive sail materials. They've also designed new navigation and control schemes for a potential diffractive light sail mission orbiting the sun's poles. With the new funding, researchers will work on optimizing the sail material and perform ground tests in preparation for a future potential demo mission. While it's funding the diffractive light sailing concept, NASA already has other solar sail missions planned. When the Artemis 1 uncrewed test flight to the moon launches later this year, it will carry with it the NEA Scout, a small spacecraft powered by solar sail technology designed to visit near-Earth asteroids. To reach asteroid 2020 GE, NEA Scout will unfurl a solar sail, demonstrating how well the technology works in deep space. Meanwhile, in late 2022, NASA's Advanced Composite Solar Sail System will deploy a solar sail from a CubeSat. After that, Solar Cruiser, an 18,000 square foot solar sail technology demonstration, will use sunlight to travel toward the sun in 2025. There are also non-governmental entities developing the technology. In 2019, the US-based nonprofit Planetary Society launched LightSail 2, a spacecraft currently operating under an extended mission to advance solar sailing technology further. With so many advancements in technology and years of research coming together, it seems like it is only a matter of time before a new method of space travel is unveiled to the world. If you enjoyed the video, please check out this one, which takes a deeper look at the Voyager missions and how they continue to make discoveries in deep space. Do you think humans will ever travel outside the solar system? Please share your thoughts in the comments section below.